Hello and welcome to another UCLA SolidWorks Student Leader Program video. In this video, we're going to be working through another practice part for the CSWA exam. This part, as shown right here, will utilize reference geometry pretty heavily, so we'll be getting into that. So let's start off by taking a direct look at the drawing itself. So you may notice that there's only part A, there's no parts B, C, D, and so on and so forth. So therefore you will not be required to use global variables, and as you can see there are no global variables given on the left over here. So just taking a quick look at the setup of this part, the unit system is millimeters, grams, seconds. There's 2 decimal places, part origin arbitrary, and the material type is aluminum, and they give you the density here. As I said before, in previous videos, that's very useful to double check this density given in the drawing with the density that SolidWorks actually provides to make sure that you're using the right material for your part. So taking a closer look at the actual drawing, we have this isometric view on the left, pretty standard. And in the very center, we kind of have our quote-unquote model view. As I've said before in the drawing views video, you should go check that out if you haven't already. The model view is kind of the central view from which all of the other projected views are, well, projected off of. So you can see that this central view here contains everything that you need to build the part, at least from a top-down sense. And then all the other views that tell you how to create all the other features are projected off of it. So you can see that it says section AA. So this, you can see A, and you're looking down at the feature from the side. And on the other side, you have section BB, which corresponds to this feature, looking at it from this side. And on the very bottom, you have another projected view, and this time from a side view. And this gives you the dimension that the thickness of this base plate is 8 millimeters. So just in terms of thinking through in a sketching mentality, the very first feature that we will logically create is this main base plate over here. And then after that, we're going to be creating this feature and that feature on top of that base plate. So that's pretty simple. So in order to create that base feature, of course, we would have to create this central view. But when you're sketching, it's always good to have some sort of methodology, some sort of a structure on how you're going to approach this sketch. So for the purposes of this demonstration, we're going to be working in a counterclockwise direction, and we're going to start at the central set of circles here. So there's the hole, and then there's also the circle forming kind of a tangent with the sides. And we're going to work counterclockwise. So working in a sort of methodology like this allows you to make less mistakes in your sketches and therefore get more accurate sketches. So after we have created this base central sketch over here, then we'll need to extrude it 8 millimeters up. And once we have that, we'll actually need to make use of reference geometry. So reference geometry is basically geometry that can be used to create other features off of. In this case, we're going to be using a reference plane, actually 4 reference planes. Our first reference plane is going to be created with this central axis passing through this circular cutout here. And it's going to have the axis as one reference, and it's going to be perpendicular to this face over here. So that's going to create a plane that kind of looks like this. Right? Then we're going to create another plane using the same axis as one reference, but it's also going to be perpendicular to this other face over here. So you're going to end up with another plane. Let me see if I can sketch it, kind of looking like that. So you have 2 planes at a sort of angle between each other. And off of those planes, we're going to be creating 2 more planes. And these planes are going to be the planes that are going to be used to create this sketch and this sketch. So those planes are going to be a certain distance offset from the original planes that we just created. So it's going to be offset here, and it's going to be offset here. So how much is that offset? Well, we can just look actually in our central model view here, and we can see that the offset is 34 millimeters. Okay, so that's basically a rough overview of how we're going to be creating this part. So without any further ado, let's hop on over to SolidWorks. We're going to go into the top left hand corner, click File, New, Part, and we can see it automatically created a part with MGS, which is what we want. So as usual in my parts that I've created before, I always start with defining the material first so you don't forget about it later. It's pretty simple. Right click on material, edit material, and we want 1060 alloy. So we'll just type in 1060 alloy. Pops up, and looking back at our drawing, we can see that the density should be 2700 kilograms per cubic meter. So we'll just check that in SolidWorks. And indeed, it says 2700 kilograms per cubic meter. So we know that we're dealing with the right material here. Click apply, click close. Now you might be wondering, on which plane should we start our base geometry? Well, looking back at the drawing in the isometric view, you can see that it's likely going to be the top plane because it's facing up. So we're going to create a sketch on the top plane. And we're going to start, as I said before, from this bottom set of circles. So you can see that this inner diameter circle is going to be 18 millimeters, and then there's going to be a concentric circle that has a radius of 18 millimeters. So we'll go ahead and create that. So we have one circle and then a larger circle. Create a dimension, 18. And the outer one has a diameter of 36 millimeters because it's 18 times 2. And in order to change this from a diameter dimension to a radial dimension, we can just click on the dimension. And on the left here, you can click on liters, then click on this little toggle that goes to radius, and you can see that the dimension display has changed to radius. So now we have successfully created our first set of the two circles. So next what we're going to create is going to be this line right here. So we'll go ahead and do that. And that line is going to be both coincident and tangent to this outer circle. So right now, as you can see, it's coincident, but I also want to make a tangent. Okay. Let's extend this out a little bit further. And next what we're going to create is going to be this set of two circles. So the inner diameter is going to be 12. And the outer circle that's concentric with that circle is going to have a radius of 12. So we'll quickly create that. And the outer circle is going to have a diameter of 24 millimeters. And this outer diameter, we want to change it to radial. So radial. Okay. But we need one more dimension for this set of circles. We actually need to utilize this 82 millimeters dimension. So that's from the center of this circle to the center of this circle. So we'll go ahead and create that. (82). Move this up a little bit. Okay, then next thing that we're going to be sketching is going to be this horizontal line here. And note horizontal. We're going to make that line horizontal. We're going to constrain it to be horizontal. And that's going to allow our sketch to be fully defined. And this horizontal line is going to be 18 degrees away from that first line that we created down over there. So horizontal, 18 degrees, and we're gonna make that line tangent to the circle. Okay. Next we're going to draw this line over here, and we're going to put a sketch fillet on it that has a radius of 42 millimeters. Okay, so the line, and then we're going to make a sketch fillet. So we have our line here, put at some arbitrary angle, and then go to sketch fillet, which is right here. Click on the two lines, and change the fillet parameter, or the fillet radius, to 42 millimeters. And we're just going to move this dimension over here just so that you can see it easier. Okay, then next we're going to create this set of circles over here. Inner diameter 8 millimeters, outer radius 8 millimeters. And we're going to make this line tangent. Okay, and the next dimension that we're going to utilize is going to be this 48 millimeter dimension. So it's, as before, it's going to be from this center to that center. Awesome. So the next dimension is going to be this 22 degrees over here. This is the angle of this line with respect to this line. (22 degrees). Then the next dimension that we're going to utilize is this 54 degrees constraining this line with respect to this horizontal line here. So 54 degrees. And this line connects that circle to our original circle. Set a tangent. Set a tangent. And dimension of 54 degrees. And we can see that we just forgot one constraint over here. This is supposed to be tangent. And now we can see in the bottom right hand corner, the sketch is fully defined. That's good. So next, as you can see, this is not a fully closed sketch. So we're going to have to use the trim entities tool. Just trim away that circle, this part of the circle, that circle. And now it's fully closed, so we can actually do an extruded boss base. So head over to Features, Extruded Boss Base, and as mentioned before, the height of this base plate is 8 millimeters. Click OK. So now this is where we start getting into some of the, I guess you could say, more advanced material. First thing that we're going to want to do is create those two initial reference planes that we're going to have offset away from the actual sketch planes that we're using for those two stand-up features. So in order to create that, we're actually going to utilize an axis through this central hole, as I said before. So we're going to go up to Reference Geometry, click Axis, and all you need to do is just click anywhere on this circular cutout and it'll automatically create the axis through the center. Click OK. And just for sake of readability, we're just going to increase the height of the axis so you can see it easier. And next we're going to create those two original planes. So go up to Reference Geometry again, click Plane. And our first reference is going to be the axis, second reference is going to be this face. And you can see that automatically made it perpendicular, which is what we want. Click OK. And we're going to create another plane in much the same way. Click on the axis. Click on the axis. And click on this face over here. Click OK. Awesome. So I'm just going to slightly extend this over here. Okay. So now we have our two original reference planes, and we're going to make another two planes that are referencing these two original planes, if that makes sense. So we're going to go up again, Reference, Plane, click on this plane over here, and we want the offset to be 34 millimeters. As you can see, the offset is 34 millimeters here, as well as 34 millimeters here. And we want to flip the offset because it's obviously in the wrong direction. Click OK. And we're going to do the same with this plane over here. And this time it's in the right direction. Click OK. And just so that stuff doesn't get really cluttered, I'm just going to hide the original two planes. Select both of them, click Hide. And now we have our two sketching planes. And I'm also going to just hide the axis. Okay, so what do these little two stand-up things look like? Well, as you can see from the section views, AA and BB, we can see that they have one line that is kind of vertical, it's perpendicular, so as you can see also from the isometric view, it's perfectly in line with this face over here. And then you have a set of two circles here, and then you have another kind of angled line, which is 16 degrees away from the original line that we're going to draw. And it's basically the same geometry for the second feature, except that it has different dimensions. We're actually going to create this feature first, so this feature is going to be on this side. So for that, we're going to be utilizing plane 4. So click on plane 4, sketch, going to view it normal to it, and SOLIDWORKS sometimes gives you a slightly interesting way of viewing it, viewing the plane normal. So we would actually want, okay, so we want to sketch on this side in order to make the feature actually show up properly in an isometric view. So the first thing that we want is going to be a line. So line here. Then we want the set of two circles. So one circle here, another circle inside of it. Set this tangent. And looking back at our drawing, we can see the dimension we need to give for these circles. For the inner circle, diameter of 8, outer circle, radius of 8. Change that to radial dimension. Okay, and we need one more line, actually, sorry, two more lines. So one line going down here, and another line going back up there to close the sketch. And this line is going to be 16 degrees away from this line. 16. Okay, so as you can see, it's still not fully defined. Right, because we need one more dimension. So that last dimension is going to be 46 millimeters from the bottom to the center of that circle set. 46 millimeters from here to there. It's going to be 46. Awesome. And we're just need to go into trim away that, and it becomes a closed sketch. So, how thick is this feature going to be? Well, looking back, we can see that both features have a thickness of 6 millimeters. So we're going to create an extruded boss base, set it to 6, and we need to make sure that's on the right side. So, yeah, that's on the right side. So as you can see before, our reference plane is 34 millimeters away from the center, but the sketch should be extruded on the opposite side. Relative to the central circle over here. So as you can see, it's creating on the opposite side, so we're on the correct side. Click OK, and let's just check that it's in the correct orientation when we look at it in isometric view. And yes, it is in the correct orientation. So I'm just going to hide plane 4 because we really don't need it anymore. Hide it. And next we're going to create our last sketch on plane 3. We're just going to click line, going through basically the same process as we used for the previous sketch. Tangent. Another line down to here. Going up. And we can add some dimensions. So we can see that inner diameter is 12 millimeters, radius of 12 millimeters. It's 46 millimeters away from the bottom, and there's a 12-degree angle between those two lines. So 12 degrees, 48 millimeters here, and 12 millimeters. And I'm just going to trim away this section. And lastly, we're going to extrude this one also 6mm. And let's just check it's on the correct side. And you can see it's on the wrong side. It should be opposite to this central hole here. So we're going to flip it and press OK. Let's just double check from an isometric standpoint that everything looks correct. So just compare. Yeah, it looks the same. Awesome. So just double checking everything. We have our material already defined. We have all of our features that we need. There's no fillets of any sort that we need to apply. So yeah, we can say this part is essentially done. So always remember to save your parts, of course, but also remember on the CSWA, they want you to check your mass properties. So we're going to go up to evaluate, click mass properties, and you're going to get your mass here in grams, and you're going to enter that into your testing client. Okay, congratulations to all of you who made it this far. Make sure to check your masses with answers on our website, links down in the description. Also, make sure to check out our website for everything pertaining to what we do as a student organization here at UCLA. And if you're a UCLA student, make sure to join our Slack channel where we'll be posting important updates on vouchers, events in the UCLA area, how we're dealing with our club in the fall, all that good stuff. So thanks for tuning in, and I'll see you next time.